Asking an AI to trace a single codebase request cost 200,000 tokens. Then, by giving the AI a simple map first, that cost dropped to 80,000 tokens.
Yeah, that is a massive drop in wasted computational effort. I mean, we're literally changing the starting line here.
Welcome to the Deep Dive. I'm really glad you were joining us today.
We have a pretty fascinating shift to talk about.
We really do. You know, I still wrestle with prompt drift myself, especially when I ask an AI to analyze a massive project and it just gets hopelessly lost.
No, absolutely. It's incredibly frustrating when it just spins its wheels.
Exactly. So today we are exploring Graphify. It's an open source tool that basically gives Claude Code a reusable memory.
Which is something developers have been desperately asking for.
Right. We'll cover how it builds a map of your repository. We'll look at the 3-pass system it uses to understand your files.
And we'll see how it fundamentally changes the way AI interacts with codebases.
Okay, let's unpack this. We know AI gets lost in big projects. Why does that actually happen?
Well, mainly because it totally lacks inherent structure when it begins.
Right.
Normally, Claude Code searches file by file. It spawns these little explore agents, opens folders, and just, builds context from zero.
It's kind of like trying to navigate a new city by walking down every random alleyway to see where it goes.
Yeah, exactly. It's chaos.
Versus just looking at a subway map before you leave the house.
Right. And graph.The fixes this by turning the repo into a knowledge graph first. It builds that subway map.
Why does crawling a repository manually eat up so many tokens?
Because the AI is wasting context windows just trying to figure out the shape of the project before it even begins to answer the actual prompt.
So it builds a map first, saving the AI from wandering blindly.
Yes, exactly. And the way it accomplishes that is really methodical.
It uses a 3-pass approach, right? How does it start?
Pass 1 focuses purely on the code. It uses a tool called TreeSitter to read the code structure locally. Classes, functions, imports, and this pass is completely deterministic.
Wait, let me stop you right there. What does deterministic mean here?
It follows strict logical rules without any AI guessing involved.
Got it. So it just reads the actual mathematical connections.
Right. No LLM hallucination yet. Beat? Then Pass 2 handles audio and video. It uses faster whisper to transcribe media files.
Like internal demo videos or meeting clips.
Yeah, exactly. Those transcripts are added directly to the map.
Wow, that is incredibly useful for capturing raw institutional knowledge.
It's a total game changer. Then we hit Pass 3. This is where the large language model steps in for documents and images.
Like PDFs and markdown files.
What's fascinating here is how it blends rigid logic with AI interpretation. It understands the business logic in a design PDF and connects it back to the code from Pass 1.
If Pass 1 is free and local, why do we even need the LLM in Pass 3?
Code is rigid and easy to map, but human context, like design PDFs, requires AI to interpret the meaning.
It reads code rules exactly, then uses AI for the messy human stuff.
Exactly. It creates a complete picture. So once that map is built...
What does this web of data actually look like in practice?
Right. It breaks down into 3 core parts: nodes, edges, and communities.
Let's define those for everyone.
Nodes are the distinct entities: a file, a function, or a document.
Okay, isolated pieces of information.
Edges are the lines connecting those individual nodes, the actual functional relationship.
On communities.
Communities are organic clusters of highly related nodes, like neighborhoods in our subway map.
The developers ran a really great demo of this on the Open Design repository.
Yeah, it's a huge open source code base. Perfect stress test.
Graphify scanned 203 files in about 6 minutes.
And it created 197 distinct nodes, plus over 3,400 edges.
That is a massive web of dependencies.
Yeah.
And it found 109 communities, right?
Yeah. It highlights surprising connections. It even identifies these things called God nodes.
Ah, the highly connected critical parts of the repo. Whoa.
Yeah.
Beat. Imagine scaling that. Imagine seeing God nodes in a code base you've worked on for years but never truly understood.
Well,
Beat.
It completely exposes the hidden, fragile architecture of your project.
What practical value does knowing the communities give to the AI?
It allows Claude Code to isolate the specific neighborhood of code it needs to solve a problem, ignoring irrelevant files entirely.
Nodes are things, edges are connections, communities are specific code neighborhoods.
That perfectly summarizes it. It's why it beats traditional search.
Since we're talking about memory, listeners are probably wondering how this differs from graph.The.
They do sound similar, but the core difference is that Graphify does not use embeddings.
Let's clarify that. What are embeddings?
Translating text into numbers so AI can find similar underlying meanings.
Here's where it gets really interesting. Graphify maps actual existing structural relationships. graph.The searches giant, unstructured document collections.
Exactly. GraphRag finds things that sound related. Graphify reads exact, deterministic relationships that already exist, like code imports.
It's basically RG Lite for repositories.
Yeah, mapping reality, not probability.
So if I have 10,000 messy policy PDFs, I shouldn't use Graphify.
Correct. GraphRag is for massive, unstructured text. Graphify is for structured systems where you want to know exactly how A connects to B.
Graphify maps structured systems. GraphRag searches giant piles of loose documents.
Spot on. You have to choose the right tool for the job.
Let's get back to the practical payoff. Time, money, and keeping this map alive.
The token savings are very real here.
In that test, asking Claude to trace a design request, the standard run cost 200,000 tokens.
And 150,000 of those were wasted just on Explore agents.
The AI was just frantically bumping into walls.
Right. But the Graphify run took only 80,000 tokens total.
That is about 40% of the original cost.
Now, I do want to warn listeners not to expect the massive 70 times token savings hype you might see online.
Yeah, the internet loves to exaggerate.
Always. But 40% is still massive for big projects.
And setup is incredibly easy. You just ask Claude Code to install it.
You just run /graphify. And there's this really cool -- Obsidian flag.
Which turns the map into an Obsidian vault for personal notes.
It's so fun to visually explore your codebase that way.
But code changes daily. How do we keep this a living repo?
You run Graphify hook install. It rebuilds the map automatically on every single commit.
If my team pushes 50 commits a day, won't updating this map get incredibly expensive?
No, because the structural code updates don't use the LLM API. They just use the local free parsing tool.
The hook updates the map locally and for free on every commit.
It's completely sustainable.
So what does this all mean? Graphify isn't just a cost-saving trick.
No, not at all. If we connect this to the bigger picture, it's a fundamental shift in how we work with these tools.
We are moving from treating an AI like a search engine that has to rediscover your project every morning to giving it a permanent living memory.
This raises an important question about the future of development. It gives the AI genuine situational awareness.
Think about the Obsidian export feature. If Graphify can instantly map the complex logic of a massive software project and turn it into a visual vault, actually wait.
Yeah.
What happens when we start pointing these deterministic mapping tools at our own personal hard drives, our personal notes, or our scattered thoughts? 2 sec silence.
That is a pretty wild concept to think about.
Try pointing Graphify at your messiest project this week just to see the map it generates. Thanks for joining us on this deep dive.